This is an introductory video over what we do with conversions. It's really not conversion problems that we have in chemistry, it's problems in chemistry that we solve using conversions. So I've organized it into three sort of buckets that you can kind of place most problems, but of course there'll be more complex problems as you go on in chemistry that maybe include some parts of what you'll see in these next few videos on dimensional analysis, which is a type of way we'll use conversions. I call them changing the ratio problems, which involves conversions, and then making a ratio like density. That's the easiest type. So there's really just, again, three sort of ways in chemistry that you are introduced to conversions. And the easiest one, again, is called making a ratio. Or for example, if we have density, we have to find some grams of a object, its weight, mass, I should say, and we have to divide it by its volume, and usually that's in milliliters. We take and have to determine, there we go, an I, what the density would be. So the density we know is equal to grams over milliliters, that object, and we usually use water, do we displace it, and we determine its mass, this object, and we determine how much water it displaced, some volume change as you put the rock in. That's making a ratio. Pretty straightforward. Those are easy types of conversion problems that students can usually do. The second one that's a little bit harder, called sort of changing the ratio, involves what I call kind of expanding or reducing the ratio through changing the ratio. So let's say they give you some given A over B, and it can be inches per centimeter, kilograms per milligram, or sorry, I guess that wouldn't be, that'd be a conversion within a unit. Let's say they say eggs, 12 of them per dozen, chicken nuggets per box, number of pencils in a container of, I guess, a box. So there's some things that you can have a set ratio. It's sort of a given ratio. And what they'll ask in the question is, hey, if your A or B value gets, either one, can't be both, but if one of them gets really big, so let's say they have some new value and it's still the same unit. Let's say it's like square footage for carpet. They say you have a room that has 100 square foot, and you know for every square foot you pay $10. That's a lot of money for just a square foot, but 1 square foot is $10. So you expand the amount of your carpet. It's 100 square foot, not just a square foot. So of course, then you have to find out what B is, and B would get bigger because it's just changing the ratio. You have to keep the same proportion. So 1 apple to 2 oranges, 2 apples to 4 oranges. So maybe a 1 to 2. You have to stay within 1 to 2. So that's kind of changing the ratio. I'll just put a name to that. I didn't do that for this, but changing the ratio. And students are usually pretty good at these types of problems. In fact, they kind of want to use it to just solve everything. Just changing the ratio sort of formula where they can cross multiply, because you know that if you have 3 of these 4, let's say they gave you the given ratio and then they gave you the number that increased and you would solve for B. You know you can just do cross multiplication to solve for X, whichever of these 2 is not known. But again, you can go small too. I could have made the set ratio and then have something very, very small. Well, then B would have to get very, very small. So that's changing the ratio. Now the hardest one, that's going to take up the bulk of the support videos that I have, is not changing the ratio or building a ratio. It's dimensional analysis. It's also maybe called, maybe in a more layman's terms, fence post calculation. Fence post calculation. We call it the conversion train. So you're going to learn in the videos to follow that the first thing we do is we identify the end. What do they want to, I guess, get to? What is it? The unit. So the unit usually is, we call it the caboose. So you're going to look for a unit that they're wanting, whether it be temperature. We'll call it the caboose here, and I'll misspell it. They want to know maybe the unit that you're ending with. That's going to be a giveaway. Like, let's say they finally say, and so therefore, what is the change in temperature if we do this much work on the system or something like that? That would be something you would write on the very end. It'd be kind of on the end. We'd say X, and then we'd say whatever that unit was. Let's say it was temperature, and they say reported in Kelvin. We identify the end. And then second, we look for what's the starting point. The starting point. And the starting point is usually an extent, meaning some amount. So we have to identify the starting point, and usually that's some sort of amount. Like, it doesn't have a ratio. It doesn't say grams per milliliter. It says just, hey, we have some 10.5 grams. So it's usually a standalone value, might be the best way to say it. Value. An extent is what we say, and maybe the science is. Then last, and I'm almost out of space here, and we'll again look for those 3 steps as we do fence post calculations. Identify the end. What do they want? Where are we starting? What's the starting point in our fence post calculation? And third, we're gonna have to build some conversion cars. Conversion cars. And those conversion cars are basically going to just be ratios. So, for example, we had up here grams per milliliter. You'll want to look for in the reading, anytime you see a ratio, something that says per this or that, that's a conversion car, and you can link them up between the beginning and the end. So in the end, you're going to have a starting point. You're going to have these conversion cars. You're going to put an equals, and you're going to have your end point. So it's really those 3 parts. 1, I guess we had this one as 1, our end. 2 is our starting point. And then you have these conversion cars that we have to put in the middle to connect the beginning to the end. That's an overview of where we're going with the videos that I have posted that involve problems in chemistry using conversions. Bye-bye.